Howdy. I'd like to look at the second lesson in Unit 13. Unit 13 is all about finding volume of pyramids, cones, and spheres and other things. Today, we are talking about the volume of spheres and hemispheres. To get started, I'd like to look at the warm-up on page 19, and I need to make a quick correction. If you notice up here at the top, it says the apothem is 8.7. That is not correct. The apothem is actually 2.75. You can see the apothem is right there. What this should say, instead of the apothem, this should say the altitude is 8.57. And the altitude is going to go from this vertex up here down to the very middle of that regular polygon. That polygon, since it has 5 sides, is called a pentagon. The formula for the area of a pentagon, and if you want to pause the video as a reminder, of course, pause it and work these on your own and see if you can do it correctly. It is a warm-up. The area of the base is the apothem times the perimeter divided by 2. So I need to take a moment and find the perimeter. Well, it says here that each side is 4, and there are 5 sides, so the perimeter is going to be 20 yards. So the apothem is 2.75 times 20 divided by 2. And that works out to be 27.5 square yards. And true to form, I've put this in the wrong blank. It should be down here. The next thing is to find the altitude. And of course, it told me right here what the altitude is. It's 8.57. So the altitude is 8.57 yards. And finally, the volume is the altitude times the area of the base divided by 3. And I'll have to do this on my calculator. So we've got 8.57 times 27.5 divided by 3, giving me 78.56. 78.56 is going to be the volume of that shape. And so now let's move into the topic itself. If you will flip to the beginning of 13.2, it's on page 7. You can see perhaps a little better on this in the color form. This is a sphere. And in a sphere, if you sliced it right through the middle, you would end up with what we call a great circle. This is the biggest circle that could go around by slicing that sphere right down the middle. It would go through the center, and of course this line right here is the diameter. It's the farthest distance from one point on the circle through the center to the other side. But just from the center to the side is a radius. So the diameter, of course, is twice the radius because it is a circle. It's the great circle because it's the biggest circle that would fit in there. If you thought about this being a ball in a hula hoop, it's the biggest possible hula hoop that we could fit in there. The volume of a sphere is given by this formula. 4 times 3.14 times r cubed over 3. Sometimes this is written like this, 4/3 pi r cubed. That's the formula for the volume of a sphere. Now, a hemisphere is just half of that. It's the top part, or the dome of a sphere. And so, of course, that would have half of the volume of a regular sphere. So let's look at example 1 here. And on this one, the radius, of course, as it says, is 4 inches. And so the volume then is going to be 4. If I could write here, the volume is going to be 4 times 3.14 times 4 cubed all over 3. And so let's put this in the calculator, and you can watch how I do this. You could use the fraction function. In fact, I'll do that way first. So if you press alpha F1, you see this first one is a frac, so hit enter. That's the alpha F1 and hit enter, and it gives me a fraction, and I want this to be 4 times 3.14 times 4 cubed. And this little caret, this little up arrow looking thing, that gives me an exponent, so 4 cubed. And then down here on the bottom, I've got the 3, and that works out and gives me 267.94. If you wanted to, you could actually do it without the fraction function, and it would look like this: 3.14 times 4 cubed. And then when you want to hit divided by, you actually have to use the over arrow and then do divided by 3, and that'll work out and give you the same thing. So the volume here is going to be 267.95, and since it's volume, it's inches cubed, cubic inches on that. Okay, so the next one talks about a hemisphere, and it says, what if the diameter is 12? Well, if the diameter is 12, the radius is 6. And sometimes if you're not paying attention, you get a little confused between when they're telling you the diameter and when they're telling you the radius. It's not intended to be a trick, but you do have to pay attention to that, because sometimes you need to know one and sometimes you need to know the other one. So you just got to be on the ball on that. And so now the formula then, of course, is going to be the volume is 4 times 3.14 times 6 cubed all over 3. Now this, of course, is the volume of the sphere. The volume of the sphere. And so in my calculator, it's 4 times 3.14 times 6 cubed. And again, use the over arrow, divided by 3. And I get 904.32. Move this over here. 904.32. And then to find the volume of the hemisphere, I'm just going to divide it by 2. Because the hemisphere is only half the sphere. So it's 904.32 divided by 2. And we get 452.16. And again, that's going to be units. Doesn't look like it told me a unit here. So units cubed, because it's volume. Now some of you may, instead of using this 3.14, you may prefer to use the pi button on your calculator. And if you use the pi button, that's fine. It's right here above that up arrow. You can see it maybe in blue. And then your problem would look like this: 4 times pi times 6 cubed divided by 3. And it's a slightly different answer because it's got a few more decimal places than 3.14, but either answer right there will be completely acceptable. The reference chart for the area of all these shapes, of course, is on the back of your chart, and we just want to remind you of that. And you can see there, if you need to, that the radius is half of the diameter. So it's time to give it a go on your homework. As always, rewatch the video if you need to, or ask your teacher if you need some help, and we're happy to help you. Good luck, and go Cougs.